Find derivative of f of x equals the integral from the square root of x to 2x of tangent inverse of t dt. We won't do this directly, but we can use the fundamental theorem of calculus part 1. We state that derivative with respect to x of the integral from a constant to x of f of t dt is f of x, but only if it is in this form. We see that the given expression is not exactly in this form, but using the property of the definite integral, the integral from a to b f of x dx is the integral from a to a c between a and b of f of x dx plus the integral from c to b f of x dx. And so we can rewrite this as the integral from x to 0. We can use any constant, any c between the square root of x and 2x. And so we will use 0. To be safe, we can just simply use a constant c of tangent inverse of t dt plus the integral from c to 2x tangent inverse of t dt. There are a few things that we would need to iron out before we can use the fundamental theorem of calculus part 1, and that is the lower limit of integration had to be a constant. For the second integral, it is, but the first integral, it is not. We can rewrite it by switching the limit of integration by putting the negative in the front. If we put the negative in front of the integral, we can interchange the lower and the upper limit of integration, and everything else is the same. We don't need to switch the limit of integration for the second integral because the lower limit of integration is already a constant. But we're still not ready to use the fundamental theorem of calculus because the upper limit of integration has to be a single variable, the same variable as the variable of differentiation. If not, we would need to use the chain rule. To use the chain rule, we simply plug the composite of function, which is the upper limit, into the integrand. And the integrand is tangent inverse of t dt. So the answer will be tangent inverse of the square root of x. We plug the square root of x into t and dt disappear. But because the upper limit of integration is not a single variable, we would need to multiply the derivative of the upper limit of integration, which is derivative of the square root of x, or 1 over 2 times the square root of x. Plus, for the second integral, we perform the same operation. We plug in 2x into tangent inverse of t to get tangent inverse of 2x. But again, 2x is not a single variable. We would need to use the chain rule and multiply the derivative of 2x, which is 2. And so the answer, we will simplify this. There's not much we can do here. We just simply rewrite it. Negative tangent inverse of the square root of x over 2 root x plus 2 times tangent inverse of 2x. And this is the derivative of the given function.